Hey everybody, I'm gonna be talking today, going through a Jupyter Notebook, and this is specifically for Priveedly. So I just open source Priveedly. It's a way that you can collect and look at content that you find interesting, and then there's a part of it where you can build your own recommendation model. And this is the Jupyter Notebook that I open source so that you have a baseline for creating your own recommendation model. The GitHub is here, so you can get everything set up. Or if, let's say, you already have your own content reader, you can always also export that data and try to fit it to this notebook or the other way around. So hopefully this notebook is just useful for you. This video is specifically an introduction for people that might be new to working with building recommenders. If you already know how to build a recommender, just go do it. Like, this video is not for you. And if you're a complete new beginner to Python, this video might also not be for you. So I'm just trying to make something out there to give something that can provide a high-level walkthrough for some people that might be new to the steps needed to build essentially a classifier. So this is really a recommendation model that's at the end a text classifier, which means it takes text as input and it gives an output of two possible classes in this case. One class is not interesting, shouldn't read this content. The other class is interesting, should read this content. And that's kind of the basis for this feed reader, is it's either interesting or it's not interesting, and that's all we care about. Which is also why we're using a library called scikit-learn, which is really useful for building simple classifiers. Again, it's not deep learning, it's not an LLM, but it's really good at taking a complex input like text and then returning a single or a guess of probability range between the two classes that we have, which is not interesting and interesting. So let me quickly walk you through the notebook. We have a bunch of imports. It's using some dot environment variables. That means that you'll have to have a dot environment file, which is commonly used in Python. The most important thing here, by the way, is to have fun playing with machine learning concepts. That's the most important thing. So here's where the dot environment is used. You need a variable called the local database connection string, which needs to be, I think, SQL Alchemy connection string, so you can look it up. And then you pull in, so this is after you've been running Priveedly for a while, either locally or on a server for you, and you've collected enough content that you enjoy. And then you can put it all together in this content data frame, which is a pandas data frame. So a way for us to work with tabular data. And then you want to look at, like, one of the first things that you do in machine learning is take a look at your target variable, which here is whether it's interesting or not, and then start to look through what's the division. So I have an incredibly skewed data set here. I have a lot more content that's available than the ones that I find interesting. So we can see here the 1 is very small compared to the 0 column, which means I have a heavily imbalanced data set. I'm going to deal with that in a second, but maybe yours is more balanced. So I recommend, making sure you're marking things as interesting, making sure that things that you like are in your feed. So maybe you have a more balanced data set, because that would be ideal. Then I have this preparation section for the text data. I'm basically trying to clean up the fact that some RSS feeds use HTML and may or may not encode strings and these types of things. So I'm basically trying to fix for those errors. If you have a cleaner feed, you may not need all of this. Or if you use multilingual or languages other than English, then you might want to essentially change a bunch of this for yourself. I would just recommend playing around with it first, maybe training a few models first, and then starting to change if you feel like the tokens or the types of text that's coming out is not really representative or is too messy for you. then I would recommend coming back here and kind of fixing and adding and changing. When you change here, you then need to change in the rate all script. So there's a rate all script in the repo. You need to change there because whatever is done here in terms of preparation of the text for the model that you train needs to also happen at inference time. So when you're trying to, on the server that you're using, or even if you're running it locally when you're using it, and you want to mark everything as interesting or not interesting, then you want to make sure that the text is in the same way. Otherwise, it just won't work very well. So then you're going to have that clean text, and then here's just a visual gut check. So you can kind of see to the left is an example of the full text. Again, you could, if you wanted, you could print out line by line, but this just gives you an idea. And then on the right is the clean text. So hopefully it looks good enough for you. Remember, it doesn't have to be perfect. Then you can save your data, and then you can always load it that way. So if you want to try out multiple models, which I assume you will, then you can just skip to this step and load it here, and then you're good to go. Then you can continue in the notebook with the next model. The next thing we need to do is we need to make our training and test data. And for this, I use the train test split from scikit-learn. So perhaps if you don't have imbalanced data, then you can just use this line and you don't need to use this random oversampler. So I'm using an oversampler from imbalanced learn. And what that can do is essentially oversample again from the interesting bit, because again, my data skews way, way, way more not interesting compared to interesting, but your results may vary. So you might want to play around here, figure out, do you have imbalanced data? If not, just use the normal train test split. If so, then maybe you play around with this and figure out what's a good training set for you and a good balance. And then we're going to build an NLP pipeline with scikit-learn. So if scikit-learn is new to you, there's some really awesome links here, thanks to Vincent, who runs Calm Code and works for Probable, who are some of the core builders of scikit-learn. And scikit-learn is really, really useful to know if you're building personal machine learning models, because again, they can be just really small, and it's actually more efficient from a compute perspective, from a price perspective, from a data perspective, to train simpler classifiers, simpler regression models, and so forth, if you have a small data and a fairly contained problem. It's only really certain types of problems that deep learning is better than just making the problem a little bit more simple. So I highly recommend, if you're interested in building more models for yourself, that you get to know scikit-learn. Here I've built 3 different pipelines. Each of them use a TF-IDF vectorizer, which you can think of as a way of taking text data. And then, of course, we've tried to break it down into tokens, and that'll be also a part of this vectorizer step. And then on each entry level, so we can think of this as each feed level, it's going to use TF-IDF, which is term frequency inverse document frequency, which is a fancy way of saying, is this word important in all of the words across all of the documents? Here the documents are my feed entries. Or is this word special to this document in a way? Is there something about this token, this phrase, this word that makes this document special and different than the other documents? So I think that tends to work good with smaller text data sets, but you could play around with other vectorizers if you want. So that vectorizes it, and then the vectors that come out of it go into whatever the classifier is. So the next step. Here I use the SVM, which is a little bit more complex, but might be worth looking at. And then I use a complement naive Bayes, which is more simple, and complement NB is also fairly good at imbalanced data sets. And then the third one I tried out for my data, although you can try out as many as you want, is logistic regression. And that one's really simple. And the cool thing about logistic regression is it's going to give me also a span of probability, which might be useful as I'm first starting with my classifier. As I'm using it as a user in the web interface scrolling, I can kind of see, oh, this one is 5% interesting, this one's 20% interesting, so this one's 0% interesting. And for me, that was a nice starting point to kind of get an idea of how the model was working. So for each of these, we're going to do a grid search. I set up a base parameter grid with some of the different hyperparameters you can use for TF-IDF for the vectorizer. And you might want to play with those, so look at the documentation. And then I have hyperparameters for each of the models. And I recommend, again, looking at the documentation. They have pretty good descriptions of what the different things do. And then feel like playing around with it. And what this grid search is going to do is going to test across a variety of splits in the data. And then it's also going to test across my variety of hyperparameters. And at the end, it's going to tell me, hey, this is what we tested, and this is the best parameters, and here's the best model based off of the scoring, so the accuracy that it reaches. So I know it's kind of annoying, but I'm just going to ask you to start slow and test each model separately. Why? Mainly because you're probably like starting to learn maybe about scikit-learn, how it works, learn about the different models. I think it's overkill to set up a production level machine learning environment for that. But I've tried to set up here a few different folders where you can save kind of the results of each. And then eventually you may want to productionize it. And if you want to contribute to the repo with a more production-oriented setup, I would very, very happily receive any pull requests and or any new notebooks. So if you tried a different recommender and you thought, wow, this works really great, and you want to contribute back, please do. Basically, we set up the random search, cross-validation, then it's going to perform the grid search. It's going to fit the different folds. So here, 5 folds, 20 candidates, 100 fits. That it was done, so my logistic regression is done in 100 seconds. And there I have my best parameters. And we can see that it received 94% accuracy, pretty good. Not the best, but pretty good. And sometimes you don't want 100% accuracy because, yeah, maybe it's a bit overfit if so. Here we can see my confusion matrix. So I'm particularly interested in this diagonal. So the diagonal going from top right to bottom left. And that shows me what it got wrong. And so here we can see that it marked 720 things, marked them interesting that were not interesting. And then it marked a significant amount of truly interesting as not interesting. And this is a byproduct most likely of the amount of imbalance in my training data set. So the better that I can describe and have information of what's interesting, probably even this same classifier will do better. And B, most likely, it's also because it's a very simple classifier. So it's logistic regression, and I'm using a fairly simple pre-processing setup. So you might want to play with this. Again, you might want to test the 3 different pipelines here and then others. The SVC, so the support vector classifier, will take a bit longer. So on my computer, just having it running in the background takes about 2 hours to train with my data set. So just know that the SVC is going to take longer for you to train because that's how support vector machine training works in comparison with these other models. And then I can write down and save the results of the experiments in a small text file so I can look at it. I can set up the pipeline so I can test it. I can save that pipeline to experiments models folder, which it can then be all there. And then if I just want to load a particular pipeline, I can always load it using this cell. And then finally, you might want to interpret your model. What did it learn? What are interesting tokens? What are not interesting tokens? Well, the cool thing is there's this library called Lime, which helps take kind of a model and tries to search the different decision space around a particular example, and then find if you removed or you added this token, it would change the output or the decision boundary in a significant way, or the end decision essentially based on that text. And so what I have here is kind of a visual example, or it's from Lime, but I have here for your use is a visual example of taking kind of an article here, and then we can see what tokens, here words were marked interesting, what one's less interesting. So here energy is less interesting, knowledge is more interesting. Here, photos is more interesting and Hacker News is less interesting. So I would recommend kind of skimming through yours. You can also resample. You can take a look at this with many different models side by side. And then at the very end, I have a way for you to kind of look at the tokens depending on the model. So again, for SVMs, this is going to be difficult. I haven't yet got it working for SVMs on my machine, but if you have less data, it might work easier. Or if you have a better idea, I very much welcome pull requests and suggestions. But here you can also have another way of kind of trying to look at the features based on their importance for the classification task, so interesting, not interesting, and take a look. Do these tokens make sense to you? You might want to test certain tokens, and if you like it, then at the end you can save it as the pipeline pickle file, PKL file here, and then you can upload that to your server. And then when you run the rate all, you can, then use Priveedly with your own ratings. So I welcome any feedback, any questions. If anything in this video, if you're new to using scikit-learn and machine learning, I welcome any questions in the comments of this video or as issues on GitHub, and I'll try to see if I can either answer them in comment form or create more supportive videos in the future. And I hope you get started. Again, have fun. Building your own machine learning models is mainly about having a lot of fun with your own data and being able to comfortably learn, being able to comfortably maybe also then control the types of news and what you want to consume in a private and personalized and hopefully friendly way. So I look forward to your feedback.